This example is your first introduction to complete stoichiometry. In this example, I'm given a chemical equation that's balanced, and I'm given a certain mass of product. And the question is, what mass of each reactant is needed to make this mass of product? This is the power of stoichiometry. Mass is something that's very easy to measure in the lab. You take the compound, you put it on a scale, you measure its mass. A chemical equation can relate the mass of the reactants to the mass of the products given the stoichiometry. So that's what we're going to show you here. All right, let's get to it. I need to figure out the mass of Ga and the mass of HCl necessary to make 100.0 grams of GaCl3. How in the world am I going to do that? Well, the first thing I have to realize is I can't do anything with a chemical equation unless the quantities I'm working with are in moles. Grams don't mean anything to a chemical equation. The chemical equation gives you the relationship between each substance in terms of moles. So when I have grams, the first thing I have to do is convert to moles. And we know how to do that. We look at the periodic chart. GaCl3 has Ga and Cl in it. Here are the entries for Ga and Cl3 on the periodic chart. I can use those entries to calculate the mass of GaCl3. 1 Ga has a mass of 69.7 AMUs. 3 Cls have a mass of 35.5 times 3 AMUs. The total then, 176.2 AMUs. That's the mass of a GaCl3 molecule in atomic mass units. That also tells us that it takes 176.2 grams of GaCl3 to make a mole. So that gives us a conversion relationship between moles and grams. 1 mole of GaCl3 is equal to 176.2 grams of GaCl3. Now that I have a conversion relationship, I can convert. I take the number I know, 100.0 grams of GaCl3, I put it over 1 to make it a fraction, and then I multiply by our conversion relationship. I need to put 176.2 grams of GaCl3 on the bottom so that that unit cancels, and that puts moles of GaCl3 on the top. So when I multiply these fractions out, I get 0.5675 moles of GaCl3. Now remember why I had to do this. I'm trying to figure out how many grams of each reactant I need. But the chemical equation doesn't tell us anything in terms of grams. It only tells us something in terms of moles. I now know that I'm working with 0.5675 moles of GaCl3. That will allow me to relate to moles of Ga and moles of HCl. And that will help me solve the problem. Alright, so now that I have moles of GaCl3, I can finally look at the chemical equation. The chemical equation relates moles of one substance to moles of another. So there's a 2 in front of GaCl3. That means 2 moles of GaCl3. I want to solve for Ga first, and the number in front of Ga is 2. That means 2 moles of Ga. So that's our first relationship. 2 moles of Ga equal 2 moles of GaCl3. This allows me to convert from moles of GaCl3 to moles of Ga. So I take the number I've got, 0.5675 moles of GaCl3, put it over 1, multiply by the conversion relationship. I need moles of GaCl3 to cancel, so that goes on the bottom. When I multiply these fractions then, moles of GaCl3 cancel, leaving moles of Ga. So when I multiply through, I get 0.5675 moles of Ga. Now understand what I've learned here. I've learned that if I want to make 0.5675 moles of GaCl3, which is 100 grams, I need to start with 0.5675 moles of Ga. Now that's nice to know, but it's not the answer. The mean guy who wrote this problem asked you how many grams of Ga you need, not how many moles. So I've got to figure out how many grams of Ga I need. That's not hard though. If I have moles, I can get to grams by looking at the periodic chart. Here's the entry for Ga in the periodic chart. This entry tells me the mass of a Ga atom is 69.7 AMUs. That also tells me that 1 mole of Ga is the same as 69.7 grams of Ga. So now I have a conversion relationship between moles and grams, which is what I need. So I take the number I know, 0.5675 moles of GA. I put it over 1, then I multiply by the conversion relationship. I need moles to cancel, so moles of GA go on the bottom. And when I multiply these fractions through, moles of GA cancel, and I'm left with 39.6 grams of GA. Now think about what I was able to do here. Given two things, a balanced chemical equation and the mass of product I need to make, I was able to use stoichiometry to calculate the mass of reactant I needed to make that mass of product. That's how powerful stoichiometry is. Well, we're not even done yet. Stoichiometry allows us to relate the mass of one substance to the mass of any other substance in the chemical equation. So I can calculate not only the mass of GA needed, I can calculate the mass of HCl needed. So I'm going to do that. Let me save this answer, 39.6 grams of GA, so that we don't forget it. And so I'll put it on the bottom right-hand corner. And I'll erase the stuff having to do with GA. And now let's start the calculation for HCl. Okay, notice I didn't erase everything. Why? Well, I still need to know the number of moles of GaCl3 that I want to make. After all, the chemical equation relates the moles of one substance to the moles of any other substance in the chemical equation. I know I need 0.5675 moles of GaCl3. Now I would like to find out how many grams of HCl it takes to make that. So, let's look at the relationship between GaCl3 and HCl. The number to the left of HCl is a 6. That means there are 6 moles of HCl in this equation. There are 2 moles of GaCl3, so the conversion relationship is 6 moles of HCl equal 2 moles of GaCl3. Now I can convert. I take what I know, 0.5675 moles of GaCl3, I put it over 1, and then I multiply by our conversion relationship. Moles of GaCl3 need to be on the bottom so that they cancel. When I multiply through, I'm left with 1.703 moles of HCl. Unfortunately, that's not the final answer because the mean guy who wrote this problem wants the answer in grams, not moles. So I've got to convert from moles of HCl to grams of HCl. So to do that, I need to look at the periodic chart. Here are the entries for H and Cl from the periodic chart. They tell us the mass of HCl. I take the mass of H, 1.01 AMUs, and add the mass of Cl, 35.5 AMUs, and the calculator tells me it's 36.51 AMUs. Unfortunately, I have to drop the 1 because I'm adding, and when you're adding, you have to look at precision. The least precise number, 35.5, goes out to tenths place, so my answer can only go out to tenths place. All right, so that's the mass of HCl. That tells me that 1 mole of HCl is 36.5 grams of HCl. That's our conversion relationship. So we take the moles of HCl, we put it over 1, and we multiply by the conversion relationship with moles of HCl on the bottom so that they cancel. When I multiply through, I get 62.2 grams of HCl. That's the final answer. So, given two pieces of information, a balanced chemical equation and the mass of one substance in the chemical reaction, I was able to calculate the mass of other substances in the chemical reaction. In order to make 100.0 grams of GaCl3, I need to react 39.6 grams of Ga with 62.2 grams of HCl. Now realize what I had to do this. I first had to convert the mass of what I wanted into moles, because chemical equations talk only in moles, not grams. So when I have grams of something, and I'm interested in working with a chemical equation, I immediately have to convert to moles. That will allow me to get to moles of any other substance in the chemical equation. Once I get to moles of any other substance in the chemical equation, then if I need to, I can convert back to grams. That's the general plan of a complete stoichiometry problem. You start with grams of a substance in a chemical equation. You convert to moles. Then you use the chemical equation to convert from moles of one substance to moles of another substance. Then once you have moles of the substance you're interested in, you simply convert back to grams.